What's up, Internet Explorers? Mike Paez here. Hey, I'm just going to jump right into it because today I am covering what is by far my most requested topic.
Forti's origin story.
No, it's SD-WAN.
Boo.
Look, I'm going to explain what it is, how it works, and why some say that SD-WAN isn't for everyone. By the end of this video, you'll not only have a better understanding of what SD-WAN is, but you'll be able to confidently answer the question, why SD-WAN? So please sit back, relax, and let it all sink in. SD-WAN stands for Software-Defined Wide Area Network and refers to a type of network that uses software to manage and optimize the flow of traffic. Much in the same way that server virtualizations eliminated the need for physical servers, SD-WAN has eliminated the need for specialized equipment by separating the control of the network from the physical hardware. Now, if you're like, what does any of this actually mean? Well, I'll get to that. We first need to understand what makes up a network. In its simplest form, a network is just a bunch of devices connected to each other, either physically or wirelessly. These devices can be just about anything, like a server, a PC, a printer. I mean, heck, even some coffee machines are connected now.
Help me.
A local area network, or LAN, is a type of network that connects these devices within a limited geographic area, like a building, a school campus, or home. If you've ever used one of these, then you've been on a LAN. A WAN, or wide area network, spans a larger distance and often connects multiple LANs together regardless of how far they are from each other. A good example is the internet, which is the largest and most widely used wide area network in the world, connecting billions upon billions of devices across the globe. So with billions of devices to compete with, how do organizations manage traffic between multiple LANs? And more importantly, how can they ensure that their data is delivered consistently and not just lost in the mix? Well, going back to the early days of computing, these networks were connected physically, like using anything from phone lines to fiber optic cables. But as you can imagine, this really didn't scale very well. Not to mention, it was expensive. Frame relay and later MPLS improved things by removing the need to manage private cable lines and instead allowing organizations to leverage existing infrastructure, like the internet. So how is MPLS any different from just using the public internet? Well, to really understand how this is possible, let's think of the internet as a highway, and the cars driving on the highway as bits of data. And this data can be anything, like traffic going to TikTok, Netflix streaming, I mean, you name it. And just like a real highway, there could be rush hour traffic, accidents, all types of variables that go into whether or not network traffic reaches its destination. What MPLS provided organizations was a way for them to create their own HOV lane for traffic going between multiple locations. This is known as an MPLS circuit. By using MPLS, organizations can now prioritize mission-critical applications like voice over IP or video calls, giving these applications a better quality of service over less important traffic. And because using an HOV lane is much more sensible than building your own highway, MPLS became the de facto industry standard. It certainly wasn't because it was cheaper, because MPLS circuits are more expensive than most point-to-point connections, due in large part to all the equipment and service fees that are required. Despite this, MPLS was basically the only show in town, and it stayed that way for over a decade. That was until the introduction of SD-WAN. You might be surprised to hear that the concept of a software-defined WAN didn't come from a manufacturer, but from the folks who use this stuff on a daily basis. More specifically, the idea for SD-WAN came from the Open Networking User Group, or ONUG, which I'll never say again. This user group is highly influential in the industry and often discovers the use cases for solutions that aren't being provided by vendors or suppliers. One of these use cases was SD-WAN, or as it was named back in 2013, the branch office has multiple paths to headquarters use case. I wonder why they changed it. Well, the solution that this use case proposed was a better way to route traffic between sites. You see, the most common and affordable deployment of MPLS uses what's called the hub and spoke model. A hub and spoke is a network topology in which a central location, like headquarters, serves as a central point for connection to other locations. So whether it's a branch office or a factory. Which works fine, but what this means is that traffic that needs to go from New York to California first needs to make a detour through HQ in Dallas. And if you've ever had to do a layover, you know it's not the fastest way to travel. SD-WAN, on the other hand, is more like a non-stop flight, which is to say that by not relying on rigid hardware, SD-WAN has more flexibility and better performance while still providing nearly the same level of reliability and quality of service as a traditional MPLS network. Or to go back to the highway analogy, SD-WAN is less of a HOV lane and more like a traffic hub. Because instead of limiting its control to just one lane or circuit, SD-WAN takes into account all the different types of ways that data can travel from one point to the other, whether it be broadband, LTE networks, or even existing MPLS circuits. Just like how a traffic cop helps cars get to their destinations as quickly and efficiently as possible, SD-WAN helps the flow of traffic by considering things like how much traffic is on each path, how fast each path is, and how reliable it is. This allows networks to be agnostic when it comes to which service provider they use at any given location. And because organizations no longer need to rely on more and more bandwidth, SD-WAN has a lower total cost of ownership than MPLS. And interestingly enough, the cost of MPLS has gone down substantially since the introduction of SD-WAN. Let's take a look to see how these two stack up against each other. The mood's right for Cybersecurity Fight Night, and we have got quite the matchup, don't we, Jim?
You can say that again, John. We've got the relative newcomer SD-WAN going toe-to-toe with the grizzled veteran MPLS. Let's go to the tail of the tape to see how these two stack up.
First up, we got reliability. And at first glance, it looks like MPLS wins this one because it guarantees little to no packet loss.
On the other hand, SD-WAN uses the same public internet that's being held together with, quote, bubble gum and baling wire.
Aren't we all, though?
Yeah, but SD-WAN compensates for this by using software to route traffic along the most efficient path, with the least amount of hops possible. And because it's sharing the same internet as other cloud applications and services, it's content aware and can prioritize accordingly.
Well, there ended up being no clear winner in that category. Ease of management, that's a different story.
SD-WAN can direct traffic and provide failover from multiple connections, including broadband internet, 5G, and even MPLS. But an MPLS circuit requires a dedicated line connection that can take up to 90 days to set up. SD-WAN is significantly less expensive to deploy and operate than MPLS. Studies show that the average monthly recurring cost of a 100 meg MPLS connection is around $1,200. Compare that to SD-WAN, around $300 a month on average. That's nearly a 75% cost savings.
And considering that SD-WAN can route traffic over MPLS networks, organizations don't have to choose between reliability and ease of management.
It's easy to see why SD-WAN is the odds-on favorite in this bout.
Well, that's all for this episode, but that's just barely scratching the surface of software-defined networking. I mean, I didn't even get into secure SD-WAN, SD branch, or SASE. No, not that kind of sassy. Sassy. No, I know. I can't believe they named it that either. But seriously, though, there is still so much left to cover, but that's going to have to wait for another episode. But if you can't wait, we have a 40-minute webinar on April the 11th covering both SASE and SD-WAN, so you can learn a lot more about both. Just register here. And in the meantime, if you're ready to start selling SD-WAN and SASE, we've got everything you need to get the conversation started on the partner portal. Well, I better get back to it because by the time you see this, I'll be headed to beautiful Orlando, Florida. I'll be there all week for Accelerate. So if you're going to be there and you see me, be sure to say hi. Just don't be surprised when I'm way more awkward in real life. But either way, I hope to see you there. And as for everyone else, stay safe out there, Internet Explorers.
Hey Mike.
Yeah, what's up, 40?
You do realize that Orlando is an hour away from the beach, right?
Oh, man.